Hi class, this is lesson 8.1, find angle measures in polygons. So our theorem 8.1 right here says the polygon interior angles theorem. So the sum of the measures of the interior angles of a convex n-gon, so any number of sides, is n minus 2 times 180 degrees. So we take the number of sides, subtract 2 from it, and then multiply that by 180 degrees. So basically, the measure of angle 1 plus the measure of angle 2 plus the measure of angle n is n minus 2 times 180. So I'm going to just write this in words. We're going to do the number of sides minus 2 times 180 degrees. So let's look at the first example. It says find the sum of the measures of the interior angles of the convex hexagon. So we have a shape with 1, 2, 3, 4, 5, 6 sides. That's what a hexagon means. So since it has 6 sides, that tells me I'm going to do 6 minus 2. I'm going to multiply that by 180. So that is 4 times 180. Which gives us 720 degrees as the total measure of the interior angles. The next one, find the sum of the measures of the interior angles of the convex decagon, key here being decagon, so it has 10 sides. So since I know it has 10 sides, I'm going to say 10 minus 2 times 180 degrees, which is really 8 times 180 degrees. Which gives us 1,440 degrees. All right, find the number of sides of a polygon now. So now we're kind of going backwards. The previous questions, they gave us the number of sides we had, and we had to find out the angle measure. Now they're telling us the angle measure, and we got to figure out how many sides we have. So if we're looking for our number of sides, we're going to say n minus 2 times 180 equals, and now we know what this equals. It equals 1,260 degrees. So now I can just solve for my n. So if I divide both sides by 180, I have n minus 2 equals 7. So to get n alone, I'll add 2 to both sides. So my number of sides equals 9. So there are 9 sides to this polygon. And that would be a nonagon. Number 2 here, the sum of the measures of the interior angles of a polygon is 1,620. Classify the polygon by the number of sides. So again, let's just use our formula. The number of sides minus 2 times 180 equals the total degrees, which is 1,620 degrees. We're going to solve for n, so we'll divide both sides by 180 degrees. So we have n minus 2 equals 9. We add 2 to both sides to get that n alone. We'll find that n equals 11. So it's n11 gon. All right, let's flip the page over. So here's our corollary to Theorem 8.1, so something we can tell because of Theorem 8.1. The sum of the measures of the interior angles of a quadrilateral is 360 degrees. This is one we just usually memorize. So it says find an unknown interior angle measure. So looking at our shape here, we want to find the value of x in the diagram to the right. So I know that my x plus my 3 other angles, 71 degrees, plus 135 degrees, plus 112 degrees. Since there's 4 sides, that has to add up to 360 degrees. So if I subtract all of these, subtract my 71 from both sides, subtract my 135 from both sides, and subtract my 112 from both sides, I'll find that x equals 42 degrees. And that would be my answer. Next one says find the value of x in the diagram to the right. And if you notice, it doesn't have 4 sides. It has 1, 2, 3, 4, 5. So we need to figure out the angle measure first. So in order to do that, I'm going to say my number of sides, which is 5 minus 2 times 180 degrees. And that gives me 540 degrees. That's my angle measurement here. So if this is an x and this is an x, I really have 2 x's there. So I can say 2x plus 68 degrees plus 105 degrees plus 109 degrees. That has to equal my total, which we figured out is 540 degrees. Simplifying that a little bit, we'd get 2x plus 282 equals 540 degrees. Subtract 282 from both sides. So we have 2x equals 258. Divide both sides by 2, and we find that x equals 129, and that's an angle measurement, so it's in degrees. All right, this next one here says Theorem 8.2, our polygon exterior angles theorem. The sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. So if you add up all the measures of the exterior angles, it's always going to equal 360 degrees. And what exterior angles are, if we take one of our sides and extend it, that would be the exterior angle here. Take another side, extend it in the same direction, that would be an exterior angle. Take this side, extend it, that would be an exterior angle. Take this side and extend it, and that would be my exterior angle right there and there. So those always add up to 360 degrees, and if you notice, I've got them drawn in on this picture. So it says find the value of x in the diagram to the right. Well, I know that those have to add up to 360 degrees, so I can say x plus 89 plus 2x plus 85 equals 360 degrees. So simplifying that, I'll subtract my 89 to move it over here, and I'll subtract my 85 to move it over here. So those cancel. X plus 2x was 3x equals 360 minus 89 degrees minus 85 degrees will leave me with 186. Divide both sides by 3, and you'll find that x equals 62 degrees. So I'm really just writing another equation using the knowledge that the exterior angles will always add up to 360 degrees. Looking at the next one, it says a convex pentagon, so 5 sides, has exterior angles with measures of 67, 77, 82, and 62. Here's my question. What is the measure of an exterior angle at the 5th vertex? So I know my 66 plus my 77 plus my 82 plus my 62 plus my x, my 5th vertex, have to add up to 360 degrees. So to solve that, I will subtract my 66 from both sides. I'll subtract my 77 from both sides. I'll subtract my 82 from both sides. I'll subtract my 62 from both sides, and this will leave me with just x. So if you subtract all of those, you'll find that x equals 73 degrees. And there's your answer. Let's look at the third and final page here. All right, it says find angle measures in regular polygons. So what is a regular polygon? I think you've all heard of this one before. It's all side lengths. I'm having a hard time writing here. All side. That does not look like the word side. That's a D, not an L. All side lengths and angle, let's say angles, are congruent. All side length and angle measurements really are congruent. So to find the measure of each interior and exterior angle, use the following. So to do this, we're going to use our total number of degrees divided by n, where n is the number of sides. Okay, so if it's regular, all the lengths of the sides are the same, all the angles are the same. So we're going to take, to find interior or exterior, we're going to take and divide the total number of degrees by the number of sides. So example 5 says the base of a lamp is in the shape of a regular 15-gon. Find the measure of each interior angle. So here's the key, interior angle. We want to find the measure of each interior angle. So for interior angles, it's the number of sides, which is 15 minus 2 times 180. That's our total number of degrees. Then we're going to divide it by our number of sides, which is 15. So simplifying that, simplify the top, you'll get 2,340 divided by 15, and you'll find the total is 156, and that's in degrees. Next one, find the measure of each exterior angle. Well, the exterior angles, no matter how many sides, always add up to 360 degrees. So we'll do 360 divided by 15, which equals 24 degrees. On your own 5 here, says the base of a lamp is in the shape of a regular 18-gon. There's a key piece, 18 sides. Find the measure of each interior angle. So for interior angles, we do the number of sides, which is 18, minus 2, and then multiply that by 180. And then to find each one, for a regular one, we'll divide it by the total of number of sides, which is 18. So if you put that into your calculator and simplify, you'll find it's 160 degrees. B, find the measure of each exterior angle. Well, we know our total exterior angles. Find the measure of exterior angle. Exterior angles always add up to 360 degrees, so if we divide that by 18, we'll find that each exterior angle measure is 20 degrees. All right, this is the end to Lesson 8.1. Make sure if you have any questions, you ask me about it, and have a great night.